In this video, we are going to take a look at mathematical expressions in real life. Let's begin. What is an expression? Well, an expression is just a mathematical statement. One of the jobs of a mathematician is to convert or turn real-life situations into mathematical expressions. So an expression is just a made up of numbers like 1 and 2 and 5 and 1/2 and -4 and 0.8. It's just numbers and operators like plus, times, minus, divide, even like squares and stuff like that. So it's just a combination of numbers and operators. You typically don't really use words in mathematical expressions to try to keep it short. So let's take a look at some examples. Imagine the following scenarios. How would a mathematician try to convert these real-life situations into mathematical expressions? Because mathematicians and scientists want to turn everything in life into just a series of numbers so that they can run calculations. So let's read example 1. Mr. Green went to the store to buy apples. He bought 3 apples and brought them home to his wife, so his wife could make apple pies. Mrs. Green yelled at him because he didn't buy enough and demanded he go back to the store because she needed more apples for her pies. So Mr. Green went back to buy 7 more apples. How would a mathematician write an expression to show how many apples Mr. Green bought that day? Okay, so all you need to do is write an expression to show how many apples Mr. Green bought that day. Well, let's look at the story. He bought 3 apples, and he brings them home so she can make pies, and she yells at him, and then he has to go back to the store and he buys 7 more apples. What kind of expression can I write? How about 3 apples, and then he has to go back to the store and buy 7 more, so it's like plus 7 more apples. And that's it. That's my expression. It's got numbers, and it's got an operator, so 3 plus 7. You may be thinking, can I do a different expression? Yes, you can. You can just say your expression for how many apples he bought could just be 10. Because he bought 3 and 7 more, which is a total of 10. Let's take a look at story 2. Sherry made $500 by selling 100 baskets of berries Saturday morning. In the afternoon, she had to refund some of her customers who returned 6 baskets because the berries were moldy. How would a mathematician write an expression to show how many baskets Sherry sold that day? So we just want to know how many baskets she sold that day. So she made $500 by sending 100 baskets. Are both of those important piece of information? No, 500 is like how much she made. Not super important to us. But she sold 100 baskets, and then 6 were returned. And so if 6 were returned, that's almost like you're losing those 6 sales. So you could say she sells 100, and then she's not adding 6 more baskets. She actually lost those sales, so it's like 100 baskets minus 6 sales. So that's how many baskets she sold that day. 100 minus those 6 that were returned. You could also write it simplified, which is like basically 94 baskets were sold that day. They're both correct. Christian. Example 3, Christian always runs 7 miles every Monday, Wednesday, and Friday. We need to write an expression to show how many miles he runs every week. So every week, he runs 3 days a week. So we can say like every Monday, he runs 7, and then every Wednesday, he runs 7, and then every Friday, he runs 7. So that's my expression, 7 plus 7 plus 7. Or you might be thinking, well, he runs 7 miles 3 days a week. So then that like just 7 times 3. Or some of you like using the multiplication dot, like 7 times 3. Yeah, 7 times 3 is also correct. Or you may be thinking another expression for how much he runs a week, 21, because that's what happens when you add 7 plus 7, or you multiply 7 times 3. Let's look at example 4. Mario went to Gino's Pizzeria to buy 4 pizzas. Gino was selling pizzas for $5 per pizza. And Mario was able to get a discount because he brought a coupon that says save $6 on your next order. So how would a mathematician write an expression to show how much money Mario paid for the pizza? So how much he paid. So let's see. He paid $5 $5 per pizza, but there were 4 pizzas, and then he saved $6 on his orders. So each pizza, because we need to write and show an expression for how much money was paid, right? So the first pizza was 5, but he buys 4 of them, right? So 5 plus the second pizza plus the third pizza plus the fourth pizza, and then he didn't spend all of that money because he got to save $6. So 5 plus 5 plus 5 plus 5, those are the 4 pizzas minus the $6 coupon. That's one expression. Or you may be thinking, well, $5 for 4 pizzas, so that's just 5 times 4, and then you subtract the $6 coupon. Or you were thinking, well, he spends $20 on pizza minus $6 coupon. Or you simplified it even further and you just said it's $14 for how much he spent. All 4 of those are correct expressions. All right, let's talk about simplifying. Simplifying, an expression can be made up of many terms and operators, like 20 minus 6 is 2 different terms, or 5 plus 5 plus 5 plus 5 minus 6, that's like 5 different terms. This is 3 different terms. Or it can be made up of a single term, like 21 is a term. It's just one number, though. 94 is a term. It's one number. 14, same thing. When you try to write an expression in the simplest way possible, it is called simplifying, or solving the expression. So you try these 2. Example 5, Mia spends 90 minutes at every school soccer practice. She goes every Tuesday and Thursday. So 90 minutes every practice. She goes every Tuesday and Thursday. You could say that's 90 plus 90. Or you could say that's 90 times 2. Or you could say 180. They wanted you to show 2 different expressions, right? 2 different expressions to show how much time she spends at soccer each week. All right, example 6, Drake weighed 170 pounds in the fall. In the winter, he gained 15 pounds, but in the spring, he lost 20 pounds. Write 2 expressions to show how much weight Drake gained, or sorry, how much weight Drake weighed. So he starts at 170, and then he gains 15 pounds, so that would be plus 15, but then he loses 20, so that's minus 20. Or you might be thinking like, oh, well, he starts at like 170 and gets 15 more, so that's like 185, and then he loses 20. Or you might just say it's 165 is how much he weighs now. All of those are correct. And there's more that you could have done as well. Using variables. So, some situations are more complicated. They include terms that are unknown or terms whose values can change. In these situations, we use a variable to create an algebraic, not just an expression, but an algebraic expression. So an algebraic expression is just a mathematical expression like the ones above, except it contains a variable as well. And a variable is just an unknown number. A variable, technically, its values can also change, but we'll talk about that later. So let's talk more about variables. Variables are written as a single letter that represents something else. Technically, you can have multiple letters represent a variable, but it's unusual, or even like an emoji. Kind of doesn't matter. But you'll most often see them as a letter, such as X or Y. For example, the variable D can represent the cost of a drink, or the letter P can represent the number of pets. So variables are just letters. They represent things. It doesn't matter what letter you use. You can use X to represent the cost of a drink, or Y to represent a cost of a drink, or you could have even used P to represent a cost of a drink. It doesn't really matter what letter you choose. You just need to know that it represents an unknown value, and it represents something in the story. So let's take a look at some examples. Alex and his little sister Beth get an allowance from their parents. As the kids get older, their parents give them more money for their allowance. Because Alex is a year older, he always gets $5 more than his sister. Write an expression for how much allowance Beth gets. So we can use a table to help figure out our expression. Fill out the table on the left and use it to write your algebraic expression below. So we need to write an expression for how much allowance Beth gets. So if Beth gets 5, how much does Alex get? Well, he always gets $5 more than his sister. That's what we know. So we just, we just add 5 to whatever Beth gets, and we have Alex's allowance. Now right here, Alex has $10. If Alex has $10, we can figure out how much his sister has, because his sister always has $5 less. So you can just say like, hey, minus 5, and 10 minus 5 is 5. What if Beth's allowance, though, is 15? Well, what would Alex's allowance be? Well, he always, remember, gets $5 more because he's older. So his allowance is going to be $5 more, which means if Alex has 20, if Beth has 15, Alex has 20. What if Alex has a allowance? We don't know what that number is. It could be 10, it could be 20, it could be 100, or 50, or 7. Who knows? What do we know about Beth's allowance? What would Beth's allowance be if Alex's allowance is our mystery number A? Well, we don't know what that mystery number is. Like we said, it could be 1,000,000, it could be 1, it could be 5. So how much would Beth get? Well, I guess technically it can't be 1, but we do know that Beth gets $5 less, regardless, because she's younger. So how much she gets, the algebraic expression would be A minus 5. So that's it. So can we write an algebraic expression for how much allowance Beth gets? Define our variable? Yes. She gets Alex's allowance minus $5. And we're going to define our variable. We're going to say A is Alex's allowance. So what this is basically saying is she gets Alex's allowance minus 5. Challenge question, can you write an algebraic expression for how much allowance Alex gets? Well, you can say A, because that's how much Alex gets, but they normally don't like that. They want you to define the variable, a different variable, or give us some more information. So we can use B for Beth's allowance. So if we knew Beth's allowance, could we figure out how much Alex's allowance is? Yes, we could. We just take her allowance and add 5 more to it, because he always gets $5 more. So the expression for Alex's allowance would be Beth's allowance plus 5, where B is Beth's allowance. Shouldn't actually be capitalizing their names, but oh well. So that's a little challenge. Oops, that's a C, not an E. There you go. Beth's allowance. Let's look at example 8. Office Depot has a back-to-school sale special where they give away a 4-pack of pencils when customers buy a notebook. Write an algebraic expression for how many pencils Office Depot gives away. Define our variable. So, okay, in their sale, they give away a 4-pack of pencils when customer buys a notebook. So if one notebook is sold, then we know that 4 pencils are given away, right? If 2 notebooks are sold, well, then 8 pencils are given away. What is the pattern to get from here to here or here to here? What are you doing to figure out like how many pencils are given away? Well, you could multiply by 4, because 1 times 4 is 4. 2 times 4, because this is like the number of pencils given away, is 8. So if 10 notebooks are sold and you're giving 4 pencils away each, that's 4, and you're adding that 10 times, repeated addition, that's the multiplication. So basically 40 pencils are given away. So they want us now to, rather than putting a number like, hey, what if they did 100 notebooks sold? Well, then that would be 400 pencils given away. But what they want us to do is they want us to write a mystery number and figure out the algebraic expression. So can we write an algebraic expression for how many notebooks are sold? Well, the number of notebooks sold would be n, right? Oh, sorry, I just noticed I forgot to do this question. So the number, so fill out on the table on the left and use it to write your algebraic expression below. Don't forget to define your variable. So we need to write down how many pencils Office Depot gives away. So how many pencils does Office Depot give away? Well, number of pencils given away is basically, it's How do I get from this way to that way? Well, if I'm going in the opposite direction, I need to basically take 4 and I divide by 4 in order to get 1. Divide 8 by 4 in order to get the number of notebooks. Divide 40 by 4 in order to get the number of notebooks sold. So 40 divided by 4 is 10. So we want to write an expression for how many pencils Office Depot gives away. Well, we would just take the number of notebooks right here, and then we multiply that by 4, and that gets us n times 4, or 4n. So that is the number of 4n is the number of pencils given away. Pencils given away is 4 times the number of notebooks sold. And our variable is n, which is notebooks sold. Notebooks sold. Sorry, I got a little bit confusing there because I was trying to do 2 things at once. So we know that our pattern is for every notebook you sell, you multiply that by 4 in order to get the number of pencils. So if the number of notebooks sold is n, the number of pencils sold is, or given away, is notebooks sold times 4, or 4n. All right, they want us to write an expression for how many notebooks are sold. Well, we want to go backwards then. Okay, so number of notebooks sold, well, if the number of pencils given away is p, how do I figure out the number of notebooks given away? Well, as I figured out above here, you just divide it by 4, p divided by 4, and that's going to get you the number of notebooks sold. So it's just p divided by 4, or p divided by 4, and p is number of pencils given away. Pencils given. All right, let's try example 9. McDougal's Burgers always sells burgers for 25 cents less than their competitor, Queen Burger. Write an algebraic expression for the cost of a McDougal burger. Well, they always sell it for less, 25 cents less, right? So the cost of a McDougal burger, you don't want to just say, oh, it's just M. You want to define it against the other thing. So how about Queen Burger? It's Queen Burger's price minus 0.25. And we have to define the variable. Q is price of Queen Burger. All right, example 10. When Gabby waters her plants, she needs 4 times as much water for her ficus plant as her cactus plant. Write an algebraic expression for how much she waters her cactus. So we know that 4 times more for her ficus than her cactus. So we've got her ficus and we've got her cactus. So if we want to figure out how much she waters her ficus, it's like 4 times more than the cactus. But if we want to figure out how much she waters her cactus, it's like 4 times less, right? And it's like you just take the ficus number of water and then you just divide that by 4. So what do they want? They want how much she waters her cactus. So how much she waters her cactus is not 4 times the amount of water she waters her cactus. It should be how much she waters her ficus, and you divide that by 4. So it should be ficus divided by 4, or F over 4, where F is amount of water needed for ficus. So F divided by 4 is how much she waters her cactus. It doesn't require as much water for her ficus or her cactus, okay? So those, now that we've explored some expressions, go ahead and try to answer some practice questions on your own. Good luck.